and answer session. We have exactly 12 minutes for question and answers.
Colaco, for the Burj Khalifa, what was the deflection factor once you went above 100 meters? Because the footprint is very huge at the bottom, but as you go up, it's pretty slender as a building. Thank you.
The deflection criteria as a maximum was a standard 0.2% of the height. But the bigger issue on tall buildings like that is what we call motion perception. Just be sure that people don't get seasick. And there are something we call ISO guidelines. And we ran a lot of wind tunnel studies to be sure that we were within those guidelines. I can go over that in detail if you like later.
Yeah. Hi, I'm Vineet Khanna, architect from Delhi. I have a question for Mr. Klinger. And most of the architects in India will agree. What are the advancements you made in structural glazing in terms of kinetics, in terms of openable windows, in terms of mosquito repellent, what we call jali shutters, wire mesh shutters? Because most of the people feel the need to open the windows often. And how do you integrate it? And that will be real success if you introduce it in India. So what are your views on that?
Opening windows is something that is needed not only for ventilation in areas that people are smoking and people want to open window to feel the fresh air. There is no need for opening windows, only for emergency or other things. In most of the high-rise building, there is not a lot of openable windows. Most of the windows that are openable is for emergency. And normally today, with the air conditioning systems that are in buildings, you don't need anything more than this. The advantage that we have in active walls is that you infiltrate the used air from the building by the air conditioning system and bring in a fresh air to the rooms, and with this used air that normally you are taking it from the building with the air conditioning, but here you use this air to cool the cavity between the glasses, and this helps for cooling the building itself. Okay?
I was particularly talking of using structural glazings in non-AC buildings. Because in India, you do not need to mandatory air-conditioned buildings. Like in Delhi now, you don't need to either cool or heat the building. You can just open the... So it has to come from, technology experts like you who have pioneered structural glazings to, it's just what we feel from the heart. So that's what...
The world is changing. People that can live without air conditioning 20 years ago in cars, today they cannot drive in these cars without air conditioning. Even in buildings, there are a lot of days during the year, and especially if you have a very heavy glasses on the building, it means that most of the energy is coming through the glass and heat the inside of the room. Glass, as all of you know, is not transferable to waves over 2,500 nanos. It means that it's the a greenhouse effect, what you get. That heat is coming with the light inside the room, hitting the inside, and cannot go out. Even if you will open a lot of windows, you cannot release so much heat from the building. And in a hot days, you will need something to cool. You can ventilate it, buy some fans or buy some other things, but normally I think that all over the world, and here especially in India, because there are a lot of hot days, even in Delhi, you will need air conditioning for new buildings. There will be no new building without air conditioning.
The question for Mr. Colaco. You have designed 60-story residential building in Mumbai and also the office building elsewhere in India. What is the structural cost per square foot? And how much is the extra premium, supposing you go from 20 floors to 40 floors or 60 floors? How much is the extra loading coming for the structure, for the cost as a whole. Since you have done the work in Mumbai, can you give us some idea what was the structural cost?
Okay. You've got a two-part question. Let me answer the first part question first. What is the cost of the structure? I do not know. On most of the projects I work on, the builders and the owners all around the world keep that secret, so we just don't have that information. Secondly, you are asking what is the premium to go taller and taller. The premiums are twofold. First of all, obviously the structure is going to cost you more, but the bigger premium is on the lifts. The lift shafts start to cost more money. But generally speaking, and this is a very long argument if you want to discuss it at a later date, there are two sides to the equation. One is, do you build tall or do you spread the city out for miles and miles and miles? Our general experience is that within reason, building taller will save cost on an overall basis for a city because you don't have to provide infrastructure very far away. But it's a study that you need to make specific for Mumbai to decide that.
Please introduce yourself. I'm Rohan from Aluplex. I have one question for you, Mr. Colaco. That is to do with, these days most calculations are done as per design code. And with more complexities in buildings and with more high-rise buildings, how imperative is it to do wind tunnel tests? Because, the calculations were obviously, the codes were always designed for standard box buildings.
The need or lack thereof for wind tunnel testing depends upon two things. First is basically the geometry of the building, the height, the shape, and so on. Secondly is its neighborhood. How do the other buildings around it impact it? We generally find that when you do a tall building, you should do a wind tunnel test for a whole lot of reasons. One of them is obviously as a structural engineer to get the wind forces on the tower. It's also very important from a motion perception standpoint. But as Mr. Klinger was saying, the cladding pressure and the behavior of the cladding is also very, very important. We have found that in an overall picture, the cost of a wind tunnel test is very low. In the United States, it's in the range of $50,000 on a project that's going to cost millions. And the safety and the satisfaction that you get from better knowledge really justifies a wind tunnel test very, very quickly.
I am B. Bashak, Dr. Colaco. Okay, I am from user group. I am certainly not a part of design team or execution team. What I understand that more and more you go vertically up, you also invite certain problem. One serious problem I can tell regarding fire safety, evacuation plan in case of any exigency and all. Could you please suggest when you talk to architect or consultant, which are such pain areas which we may not be aware of, at least we should raise and address those issues so that our building, if we go for high-rise, is safe.
Here is one thing where I'm trying to do reverse technology transfer. As a matter of fact, India has made more strides in fire safety than most other places in the world. For example, here in Mumbai, all of you know that there's a refuge floor requirement, and it's essentially all over India. That actually is a very smart way to handle the fire problem, because above and beyond making the structure fireproof, life safety demands that you be able to evacuate people. And I've seen every scheme you can think of for evacuating people, but the refuge floor is by far the most superior one there is. And it's become a law in most parts of India, and I'm trying now to take that back to America to make it a law there.
I'm Harish Gupta. I'm an architect from Bombay. My question is to Juergen. Up to what height should you start considering climbing foam, like 20 floors, 15 floors, to make an economic sense? Secondly, if you have a large complex of various sizes of buildings and various designs, do you need different design sets, or the same sets can be adaptable to different buildings? I'm talking from the point of view of investment, and payback periods.
To your first question, as I said, the high-rise buildings can be made with either crane climbing form or self-climbing form. The self-climbing form gets economical from 20 floors up. So 24 floors and less could also be economical with crane climbing form. However, it depends also on the crane capacity. If you are short of crane, sometimes it's worse to go for self-climbing form. Second, depends on the cycle time and the construction time of the buildings. We made project where we shifted the climbing forms to the next building after the first was finished. However, when the cycle time and the construction period is very tight, then the clients are forced to invest or rent a second set or a third set. You have seen in that project in Korea where they made these 15 high-rise buildings. No, it was even more. So each high-rise building had its own self-climbing formwork due to the tight time schedule. They could not afford to spend the time to shift the form.
Thank you. Thank you. I think
some of them were absolutely identical and some of them were different. Correct.